Hello children, this is Suresh Sukarma presenting Divine Public School in Mathematics of class 10th. The chapter 2. Today we are going to learn the solutions of few difficult questions which were given in the yesterday's question paper. That is based on the demand of the students that these questions are difficult for them. So for the chapter polynomial, this is given by Suresh Sukarma. So the children, the first question was the question number 11. In this question were given: find the quadratic polynomial, the sum and product of whose zeros are -3 and 2 respectively, and also find its zeros. So the children, be careful, as the sum of the zeros and product of the zeros, these two things are given in this question. So let us see the explanation of this sum. In this solution, as the sum of the zeros is given -3, so it means if alpha and beta are the zeros of this quadratic polynomial, then sum of zeros means alpha plus beta equals to -3. Understood? And second thing is given product of its zeros. Product of its zeros is equals to 2. It means alpha into beta equals to 2. So let us find out this quadratic polynomial in which sum of zeros and product of zeros are given -3 and 2. So the students, in the theory we have learned the quadratic polynomial in terms of its zeros equals to p of x equals to x square minus sum of zeros, means alpha plus beta into x, plus product of zeros means alpha into beta. So here, with the help of this formula, we have to substitute the values of sum of zeros and product of zeros in this equation. So let us substitute the values of sum of zeros and product of zeros in this equation. So x square minus sum of zeros is -3. So at the place of alpha plus beta we have substituted -3 plus into x plus product of zeros, which is equals to 2. Now simplify. X square minus of minus is plus 3 into x, 3x plus 2. So we got the answer, that required polynomial equals to x square plus 3x plus 2, which is your answer. Now in this one more question it is asking, also find its zeros, means the value of alpha and the value of beta. These are zeros. We are going to find out the separate values of alpha and beta. So for this you have to take this polynomial equals to 0. This p of x equals to 0. It means this polynomial x square plus 3x plus 2 equals to 0. X square plus 3x plus 2 equals to 0. Let us factorize it, and in the factor we will get the zeros of this polynomial. Now this x square plus 3x plus 2, we have to factorize it by the method of splitting middle term. Here in this equation, middle term is 3x. Now we are going to split this 3x in two parts, which is based on the coefficient of x square and the constant term. This 1 2s are 2 and 1 plus 2 is equals to 3 also. So this 3x can be written as 2x plus 1x. So you can write this equation x square plus 2x plus 1x plus 2 equals to 0. Now this middle term is split in 2x plus 1x. Now take the first pair as a common, x, so you will get in the bracket x plus 2, and in the second pair you will get the common one, you will get x plus 2. Now you got the 2 factor of it, x plus 2 into x plus 1, which is equals to 0. Now from these two product you will get the required zeros of this polynomial. So the first 0 is minus 1 and second 0 is minus 2. Now see the question number 12 that is asked by the students. In question number 12, this was find the zeros of the polynomial px equals to x cube minus x. This was the question. So it was very simple question, but few students have given as a difficult, so we have to give the solution of it. So let us see the solution. As your polynomial px equals to x cube minus x. So first of all, what you have to do, as you know that this polynomial is a cubic polynomial, so it has at most 3 zeros. Let us see what are there. First of all, factorize this. It is a binomial having 2 terms and both the term has x as a common. Taking x as a common, you will get in the bracket x square minus 1. Now this x square minus 1 can be written as 1 square also. Now this bracket is in the form of a square minus b square. So as you know that formula, a square minus b square equals to a plus b into a minus b. Therefore you will get the factor of this x cube minus x is, first factor is x, second factor is x plus 1, and third factor is x minus 1. Now for the zeros of this polynomial, we have to take this polynomial equals to 0. So let us suppose that px equals to 0. Now as px equals to x into x plus 1 into x minus 1 equals to 0. So from these three products you will get the zeros of this polynomial. For first product x equals to 0, that is first 0. For second x plus 1 equals to 0, you will get x is equals to minus 1. And for the third product x minus 1, you will get the third zeros is 1. So the students, these questions was very easy, and see the solution, and if you are facing any problem in this, once again you can ask. We will explain you as much as you will say. So the zeros of this polynomial, you will get 0, 1 and minus 1. Okay students, the next question is question number 15, which is verify the numbers given alongside of the cubic polynomial. Below are their zeros, and also verify the relationship between the zeros and the coefficients of this cubic polynomial. So your cubic polynomial is 3x cube minus 5x square minus 11x minus 3, and the numbers which were given minus 1, 3 and minus 1 upon 3. These three numbers we are going to verify here. These three numbers are the zeros of this cubic polynomial also. So let us see the solution of this question. In this solution, as your polynomial is 3x cube minus 5x square minus 11x minus 3. First of all, you have to compare this cubic polynomial by the standard form of cubic polynomial, which is ax cube plus bx square plus cx plus d. After comparing, you will get the values of a, b, c and d respectively. Here from this equation, you will have a is equals to 3, b is equals to minus 5, c is equals to minus 11, d is equals to minus 3. As a is the coefficient of x cube, b is the coefficient of x square which is minus 5, c is the coefficient of x which is minus 11 and d is constant term which is minus 3. And these numbers minus 1 we have taken as alpha, 3 is equals to beta and gamma is equals to minus 1 upon 3. So let us verify first of all these values are the zeros of this polynomial. So as the polynomial p of x is equals to this, so let us find out the value of p of 1. So when you find p of 1, substitute x is equals to minus 1 in this polynomial. So 3 into minus 1 whole cube minus 5 into minus 1 whole square minus 11 into minus 1 minus 3. So 3 into minus 1 cube is equals to minus 1, 5 into 1 minus 1 square is equals to 1, minus 11 is equals to minus 1 and minus 3. Next, 3 into minus 1 equals to minus 3, minus 5 into 1 equals to minus 5 and 11 minus 3 is equals to plus 8. So minus 3 minus 5 is minus 8 and plus 8 equals to 0. This p of minus 1 equals to 0 shows that minus 1 is the 0 of this polynomial. Let us see the second p of 3. In the p of 3, 3 into 3 cube minus 5 into 3 square minus 11 into 3 minus 3. So 3 cube is 3 3s are 9 3s are 27 multiplied by 3 is equals to 81, minus 5 into 3 3s are 9, 9 5s are 45 minus 45 and minus 11 3s are 33 minus 3. So 81 and these three are the negative terms, you have to add on minus 45 minus 33 minus 3, you will get minus 81. So my 81 minus 81 equals to 0. This p of 3 equals to 0. Again verify that this 3 is also 0 of this polynomial. So let us see for the third values, which is minus 1 upon 3. So let us find out p of minus 1 upon 3. So as 3x cube were the polynomial, so 3 into minus 1 upon 3 whole cube minus 5 into minus 1 upon 3 whole square minus 11 into minus 1 upon 3 minus 3. Now this 3 is simplified, minus 1 upon 3 whole cube is equals to minus 1 upon 27, 3 3s are 9 3s are 27 and this 27 is simplified by 3, 3 9s are 27, you will get minus 1 upon 9. Then minus 5 and the 5 upon 9 plus 11 upon 3 and minus 3. Now taking 9 as LCM, 9 ones are 9, so minus 1 minus 5 because denominators are same, 3 3s are 9, 11 3s are 33 and 1 9s are 9, 9 3s are 27. So minus 1 minus 5 and minus 27 equals to minus 33, minus 33 plus 33 equals to 0, so 0 upon 9 equals to 0. Therefore again when you got p of minus 1 upon 3 equals to 0, it means p of this minus 1 upon 3 is the zeros of this polynomial. Okay, after verifying that minus 1, 3 and minus 1 upon 3 are the zeros of this polynomial, let us verify the relationship between zeros and the coefficient of this polynomial. So first formula, you know that sum of zeros alpha plus beta plus gamma equals to minus b upon a. Now substitute the values of alpha, beta and gamma, which are minus 1, plus 3 and minus 1 upon 3, and the values of coefficients. B is the coefficient of x square and a is the coefficient of x cube. So minus 1 plus 3 minus 1 upon 3, we will get 3 as LCM. Minus 3 plus 9 minus 1 upon 3 equals to minus of minus 5, the value of b, so plus 5 by 3, and here 9 minus 4 equals to 5 by 3, means both the sides are equal. Let us verify the second formula of this relationship between the coefficients and the zeros of this polynomial, which is alpha into beta plus beta into gamma plus gamma into alpha, that is equals to c by a. These are the coefficients and these are the zeros. Substitute the values of alpha, beta and gamma. Alpha is minus 1 multiplied by 3 plus 3 multiplied by minus 1 upon 3 plus minus 1 upon 3 multiplied by minus 1, which is equals to minus 11, the value of c, and a is 3. Now minus 1 into 3 is minus 3. 3 is cancelled, minus 1 plus 1 upon 3 equals to minus 11 upon 3. Now let us solve it. You will get minus 12 plus 1, that is minus 11 upon 3. Both the sides are equal, you are getting, therefore it is verified. And the next, product of zeros alpha into beta into gamma equals to minus d by a, that is minus 1 into 3 into minus 1 upon 3 equals to, the value of d and a is minus 3 upon 3, that you will get 3 upon 3, that is 1 here. The simplification of these numbers is also 1, means both the sides are equal, therefore it is verified the relationship between the coefficients and zeros of this polynomial also. Thank you.